topic would be pentose phosphate pathway. We have already done with the mechanism of respiration, both anaerobic and aerobic respiration. In aerobic respiration, we find that there is glycolysis, then the pyruvic acid produced during glycolysis enters the mitochondria where it gets converted into acetyl coenzyme A, and then it enters into the Krebs cycle. And during Krebs cycle, we find that there is formation of reduced coenzymes, and the reduced coenzymes then forward their electrons and protons to the oxygen, which is the terminal oxidant, during the oxidative phosphorylation. And during this process, ATP is formed. But there is an alternate pathway for this respiration. In many organisms, a pathway occurs in the cytoplasm, and in the cytoplasm it takes place in presence of oxygen. So during this phenomenon there is direct oxidation of glucose, and this is called the direct oxidation pathway also. This pathway was indicated very earlier in 1930s by a Nobel Prize winner physiologist Barber. Later on, a little was done by Dickens on this pathway, but its full mechanism, reaction details and reaction mechanism was worked out by Horicke and Raker independently. Now strictly coming to this pentose phosphate pathway, because we are not having much time, this would be a short video. We will start how the first step of this pentose phosphate takes place. In the first step, the glucose present in the cytoplasm, it gets phosphorylated and becomes the glucose 6-phosphate. We here need 6 molecules of the glucose. They get converted into 6 molecules of glucose 6-phosphate in presence of the enzyme hexose kinase. So the first step of the pentose phosphate pathway is that there is the phosphorylation of glucose to produce glucose 6-phosphate. Now the 6 molecules of this glucose 6-phosphate get converted in presence of the enzyme. This is an actually oxidation process. Dehydrogenation takes place. The enzyme is dehydrogenase. This is hexose phosphate dehydrogenase. It converts glucose 6-phosphate into an intermediate. The intermediate is 6-phospho gluconate or glucono gamma lactone. This is the intermediate compound, usually formed for a brief time, and immediately it is converted by the enzyme lactonase. In presence of water, it gets converted into 6-phosphogluconic acid. Now during this step, that is dehydrogenation of this glucose 6-phosphate pathway with the help of this dehydrogenase enzyme, here 6 molecules of NADP, this is nicotinamide adenine dinucleotide phosphate. Remember here NADP is used. Instead, while we were discussing the Krebs cycle, we used NAD positive, that was this another coenzyme. Now this coenzyme A, this is the NADP positive, oxidized, it gets reduced to NADPH2. Simply we will call it NADPH2, but actually it is NADPH plus H positive, which we have earlier discussed why it is so. Now here, during this step, there is dehydrogenation. Now, in the next step, this 6-phosphogluconic acid is again oxidized. That there is once again dehydrogenation, but along with this, actually there is oxidative decarboxylation also. So here we can say the enzyme is 6-phosphogluconic dehydrogenase and decarboxylase, because this enzyme is both a dehydrogenase enzyme and a decarboxylase enzyme. During dehydrogenation, it gives these hydrogens to the NADP positive, which gets converted into NADPH2. Now we will call it NADPH2 instead of NADPH plus H positive for the simplicity. Here also 6 molecules would be used and 6 molecules of NADPH2 are formed. Now during this process, there is decarboxylation and 6 molecules of carbon dioxide are evolved. So the reaction results in the formation of 6 molecules of ribulose 5-phosphate. So here we can say initially we were having a 6 carbon compound. Now from each molecule of 6 carbon compound we have found here there is removal of 1 carbon in the form of carbon dioxide. So from 6 molecules of carbon dioxide are removed. So we will have now 6 molecules of a 5 carbon sugar, that is ribulose 5-phosphate. Now this ribulose 5-phosphate 6 molecules, they get converted into their isomers. Two types of isomers are here formed. One is ribose 5-phosphate. Remember, this is the very important significance of this pathway, that during this pathway these ribose sugars are formed, which are very important. They act as precursors of nucleic acid synthesis. And also one more isomer of this, that is xylulose 5-phosphate. So xylulose 5-phosphate and ribose 5-phosphate. You know we have 6 molecules of ribose 5-phosphate. Now 2 molecules of this ribose 5-phosphate are formed in presence of the enzyme isomerase, and 4 molecules of this xylulose 5-phosphate are formed in presence of the enzyme epimerase. So let us have a little recap of this. हम ऐसे कहेंगे कि ग्लूकोज 6-फॉस्फेट के हमारे 6 मॉलिक्यूल्स हैं. पहले स्टेप में हमने ये इसकी फॉस्फोरिलेशन की तो 6 मॉलिक्यूल्स ऑफ ग्लूकोज 6-फॉस्फेट मिले हमें. अब यहाँ पर पहला स्टेप है डिहाइड्रोजनेशन होती है, दैट मीन्स रिमूवल ऑफ हाइड्रोजन्स फ्रॉम दिस ग्लूकोज 6-फॉस्फेट, दैट वुड बी द ऑक्सीडेशन. यहाँ पर वो हाइड्रोजन्स एक्सेप्ट करता है NADP, तो NADPH2 बनता है. तो यहाँ पर 6 मॉलिक्यूल्स हमें चाहिए. ड्यूरिंग दिस प्रोसेस एक इंटरमीडिएट कंपाउंड बनता है 6-फॉस्फोग्लिकोनो गामा लैक्टोन, लेकिन जल्दी ही वो लैक्टोनेज की प्रेजेंस में चेंज होता है इनटू 6-फॉस्फोग्लिकोनिक एसिड या ग्लिकोनेट में. नाउ यहाँ पर दूसरा ऑक्सीडेशन स्टेप होता है 6-फॉस्फोग्लिकोनिक एसिड गेट्स चेंज्ड इन प्रेजेंस ऑफ phosphoglyconic dehydrogenase and decarboxylase, it is the enzyme, and it gets converted into the ribulose 5-phosphate. These are the 6 molecules and these would be also 6 molecules. Now here 6 molecules of NADPH2 are again formed and with the release of 6 carbon dioxide molecules. तो यहाँ पर अगर हम फिर से देखेंगे 6 molecules of ribulose 5-phosphate है हमारे पास. अब ये चेंज होता है एक आइसोमर में जिसे हम राइबोज 5-फॉस्फेट कहते हैं. तो इसके लिए एंजाइम है आइसोमेरेज. यहाँ पर इसके 2 मॉलिक्यूल्स बनते हैं, लेकिन इसके 4 मॉलिक्यूल्स चेंज होते हैं xylulose 5-phosphate में इन प्रेजेंस ऑफ एन एंजाइम दैट इज कॉल्ड द एपिमेरेज. नाउ हियर सिंपली अब हम थोड़ा सा मैथमेटिकल कैलकुलेशन लेकर हम चलेंगे. इट इज वेरी इजी, यू कैन अंडरस्टैंड इट इजीली. यहाँ से हम लेंगे कि we will take the 2 molecules of this ribose 5-phosphate and the 2 molecules of this xylulose 5-phosphate. Remember, we are taking all the 2 molecules of ribose 5-phosphate and we are taking only 2 molecules of xylulose phosphate. This would mean that we are still left with 2 molecules of xylulose 5-phosphate. Now, these 2 molecules and these 2 molecules combine in presence of an enzyme. The enzyme is known as transketolase. In presence of this enzyme transketolase, they combine to produce 2 molecules of pseudoheptulose 7-phosphate, which is a 7 carbon sugar, is and it is two molecules are formed, तो इसके दो molecules यहाँ पर बनते हैं, and besides this, here the reaction also produces two molecules of phosphoglyceraldehyde, या glyceraldehyde 3-phosphate. So glyceraldehyde 3-phosphate या phosphoglyceraldehyde 3-phosphate, तो इसके भी दो molecules बनते हैं. This is 3-carbon sugar और ये 7-carbon sugar है. So here we can have a calculation here. In the reaction we have put the two molecules of ribose 5-phosphate, that means 10 carbons, and the xylulose 5-phosphate, that means the 10 carbons. So in the reaction there are participating 20 carbon atoms. So here in the products we would have here 7 carbon sugar, pseudoheptulose 7-phosphate के दो molecules, तो इस तरह हमारे पास यहाँ पर 14 कार्बन्स हैं इसमें, and so 3 carbon glyceraldehyde 3-phosphate के दो molecules, so they would be 6 carbons, so this would be 14 plus 6, that is 20, so the reaction is balanced. Now here the two molecules of this pseudoheptulose 7-phosphate and two molecules of this glyceraldehyde 3-phosphate combine in presence of the enzyme trans-aldolase to produce two molecules of fructose 6-phosphate. तो fructose 6-phosphate के दो molecules, remember fructose is a 6-carbon sugar, तो यहाँ पर a 4-carbon sugar erythrose 4-phosphate is also produced, और इसके भी दो molecules यहाँ पर बनेंगे. So pseudoheptulose 7-phosphate के दो molecules और glyceraldehyde 3-phosphate के दो molecules, they are combined in presence of trans-aldolase to produce two molecules of fructose 6-phosphate and two molecules of erythrose 4-phosphate. Now these fructose 6-phosphate later will get converted into its isomer, that is glucose 6-phosphate, जिस पर हम लास्ट में आएंगे. लेकिन यहाँ पर हम देखेंगे there are two molecules of erythrose 4-phosphate combine with the another two molecules of this xylulose 5-phosphate, because we have left with xylulose 5-phosphate के हमारे पास अभी दो molecules हैं, तो यहाँ पर दो molecules erythrose 4-phosphate के और दो molecules of इस xylulose 5-phosphate की, they combine in presence of the enzyme again trans-ketolase, and here they produce two molecules of fructose 6-phosphate again, and they produce two molecules of glyceraldehyde 3-phosphate. So दो molecules यहाँ पर फिर से मिलेंगे हमें. So once again I will recap this कि यहाँ पर erythrose 4-phosphate जो हमारे पास यहाँ पर बन गया, ये combine होता है यहाँ पर जो हमारे पास already left है दो molecules xylulose 5-phosphate के in presence of the enzyme trans-ketolase, और यहाँ पर बनते हैं fructose 6-phosphate के दो molecules और glyceraldehyde 3-phosphate के फिर से दो molecules. Remember, glyceraldehyde 3-phosphate के दो molecules में से एक molecule change होता है इसके isomer में, that is called dihydroxyacetone phosphate. Remember, this is also a triose sugar, that means 3-carbon sugar. Now this dihydroxyacetone phosphate is the isomer of the glyceraldehyde 3-phosphate. The enzyme is triose phosphate isomerase. Now both combine now in presence of the enzyme that is called aldolase to produce fructose 1,6-diphosphate. So one molecule of fructose 1,6-diphosphate gets changed with the fructose 6-phosphate when in presence of the enzyme phosphofructose kinase. That means there is removal of one phosphate grouping from this compound. So overall, if you will see now here, We have two molecules of fructose 6-phosphate here, two molecules of fructose 6-phosphate here, and one molecule of fructose 6-phosphate here. Now, these 5 molecules of fructose 6-phosphate all get converted into glucose 6-phosphate in presence of the enzyme isomerase. So, overall, we can see now that in the reaction we have entered the 6 molecules of glucose in the form of glucose 6-phosphate, but only one glucose molecule is used which is completely oxidized to produce 6 molecules of carbon dioxide and to yield 12 molecules of NADPH2, but the 5 molecules are regenerated. So during this phenomena we may say that there is complete oxidation of one glucose molecule, and this all occurs in the cytoplasm in presence of oxygen. Now these reduced coenzymes are now then moved to the mitochondria, where in the inner membrane, they will participate in the electron transport system and forward their electrons and the protons to the oxygen to reduce it to the water, and during this the ATP will be formed. As you know, there is production of 12 NADPH2 molecules. As we know that one NADPH2 molecule produces 3 ATPs, so overall there would be 3 into 12, that means 36 ATPs would be generated by this metabolic pathway. So it is almost equal to the aerobic respiration pathway occurring by means of glycolysis, Krebs cycle, etc. That is 38 ATPs. So, but the significance of this pathway is much more, because besides it can liberate energy, it can produce energy, it is very important for producing these reduced coenzymes. These reduced coenzymes may be used in different metabolic processes, and also it is one more important significance is that it produces these pentose sugars, that is the ribose 5-phosphate. This ribose, these are the precursors. This ribose phosphate is the precursor of nucleic acid synthesis. You know that ribose can be changed into deoxyribose. So for RNA and DNA synthesis, it is very important. So it is a very significant pathway.